talking about dice. Oh, where are my dice? I don't have them. Okay, moving on. You've seen dice. Yeah, you've seen them. When playing board games, it's common to roll 2 number cubes, dice, and calculate their sum. Determine the number of possible outcomes. So those are events that happen when something happens with probability. When you roll 2 number cubes once. I realize I should highlight the word outcome because that's a very common vocabulary word for probability that you need to know. Use the counting principle. So what is the counting principle? The counting principle says if you have 5 options for your first outcomes and you have 6 outcomes for your second, you just multiply them because that's the total number of counting things that you get from the combination of those two. Since there are 6 sides to each die, dice is plural, die is 1, rolling 2 dice makes 6 times 6, that's 36 total outcomes. And here they are. Writing a sample space for rolling 2 number cubes, dice, 1 time, right? So first dice, second dice. Then when you do that, we could roll a 1 and a 1, or we could roll a 1 and a 2, or a 1 and a 3, or a 1 and a 4, or a 1 and a 5, or a 1 and a 6. So you're rolling, one dice is a 1, and the other dice is a 6, and it's recorded as that entry right there. In fact, all 5 rows I've already put on the thing for you. Rolling 2 dice, rolling a die, and the first die you roll is a 2. And rolling a die, the first option is 3. So I left the bottom one blank. Let's fill it out together. You could roll a 6 and a 1. You could roll a 6 and a 2. These are not the same, by the way, because the first die rolled a 6 and the second die rolled a 2. That's not the same as the first die rolling a 2 and the second die rolling a 6. There's like a switch that happens. And while it doesn't look so much to us if the dice are exactly the same color, when you switch up and have like a green die and a white die and then you throw them, you definitely know this is the die that were green and these are the results from the die that was white. Okay, 6-3, 6-4, 6-5, and 6-6. That's the entire sample space. There is no other possible combination of 2 dice other than all of these outcomes, all 36 of these outcomes. We can just check it by the way that the answer from number 1 is correct by counting. That's the counting principle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 24, 30, 36 total options, outcomes. Now that we have that, this is where this lesson and this topic start to get interesting. For me, at the end of the game. Every single outcome here is equally likely, but if we look at a clever combination of those outcomes, like for example, adding them, then we start to see some patterns develop, and those patterns are what we want to study. A two-way table shows the relationship between 2 data sets. So the first data set would be rolling a number cube 1 time, and then rolling a second number cube on its own another time. Complete the two-way table to represent all the possible sums from rolling the 2 dice 1 time. So if I roll a 1 and a 1, add them together and I get a 2. I roll a 1 and a 2, add them together, I get 3. So this 1 and this 3 are the 2 dice rolls, and when I add them, I'm going to put that sum into the table. 1 and 3 make 4, 1 and 4 make 5, 1 and 5 make 6, 1 and 6 make 7. Can you complete the table? Maybe you should pause the video here and complete the table. I'll go ahead and keep rolling. You skip forward and see if we have the same results. 5, 6, 7, 8, 9, 10, 6, 7, 8, 9, 10, 11, 7, 8, 9, 10, 11, 12. This is our data table from rolling the die, rolling a second one, and adding their result together. Sum of the result. Plus means sum. And then recording those results into the two-way table. This is the two-way table. So know that you know what that is, and know that you're going to be able to create your own in a stressful setting, science class, history class, whenever you have to like organize or categorize numbers, doesn't just happen in math class. When you have to do that, this is a good strategy to use. So what are the possible sums? 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, 11, and a 12. Now we know that rolling for the two smallest numbers would be 1 plus 1, so that's why 2 shows up. It's the smallest number on one die plus the smallest number on the other die, and 2 is their outcome when you add them together. The two biggest numbers on both die are 6 and 6, and when you add them together, you get 12. There's a lot of good probability there. The next up is called a frequency table, and so stick around for that one. We'll tell you all about frequency tables and how they are useful to us to, again, continue to model and represent data displays in a more meaningful and more concise way. Thanks for watching. Stick around.